Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition. We're doing problem number 2.43. I'll go ahead and read the problem statement. Suppose you have n data points, 1, 2, 3, 4, 5, all the way up to n, y and x data points, and you wish to fit a line through the origin. So the equation of the line looks like this, 2.43. Equation of the line looks like this, where a is the slope. To these data using the method of least squares. Derive equation A.1-6 from appendix A.1 for the slope of the line by writing the expression for the vertical distance, di, from the ith data point to the line. Then writing the expression for phi equals the sum of the squared. So basically the sum of the squared error. And finding by differentiation the value of a that minimizes this function. Okay, because when you take the derivative at the minimum, it should equal 0. The derivative should equal 0. Okay, so let's get an equation for di. We're minimizing the distance between the ith data point and it's just the vertical distance. Yeah, it's just the vertical distance is what di is. So we have our data point x or yi, and we're subtracting our model from that. So now we have an equation for the difference between our data point and the model. Okay? And then we need to get an equation for what the sum of the squared error is. So the sum of the squared error equals the sum of di squared, which equals, we just got an equation for that, which equals yi minus axi, and we're squaring that. Okay. Then we need to take the derivative of this function with respect to the parameter a. So when a changes, how does the sum of the squared error change? So we're taking the derivative. We can move the derivative inside the summation. Okay, and then we can take the derivative of this function on the inside. And first we do the power rule and take care of that. So we have 2 times the inside raised to the power of 1, and then we take the derivative of the inside. The derivative of y is 0 because there's no a there, and then the derivative of minus ax is just minus x. Okay, then we simplify this expression and try and figure out where it equals 0. So let's simplify this a little bit. Okay, and then we can distribute the summation to get, let's do the x term first, 2a xi squared minus 2, and we'll do the y xi summation. Okay. Now we need to find out where this is at a minimum. So where this equals 0 is the min. So let's find where that equals 0. Okay. We can move this negative term over to the other side. So okay, then the 2's cancel, and we say A equals yi divided by xi squared. And let's check what it says in Appendix A1. And sure enough, this is what the equation A.1-6 is. So we have reached the conclusion of this problem. Great, thanks for joining me on this video, and if you have any comments, please leave them down below about any questions about this problem specifically, or any other problems that you might need help with. Just let me know and I can help work on those. Thanks for joining me again, and I hope to see you in the next video. Thanks, bye.